My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 469. In this lecture, we will try to understand applications of clustering. So, since we have understood what clustering is, let's understand what are the applications of clustering. By the way, clustering actually is more studied or more deeply studied in data mining courses instead of machine learning, because some of the clustering techniques are actually developed by the data mining community and not by core machine learning community. There are tons of applications of clustering. I will walk you through few of them in this particular lecture. But if you want a good list of all the applications in various areas, what I would recommend you would be go to Wikipedia, a favorite source for all data anyway. We can go to Wikipedia. There is a page, cluster analysis, in which if you go to applications, we will get huge list of applications, everything from biology to medicine. There are like huge number of applications here. So just to repeat myself, the page is page for cluster. This is page for cluster analysis applications. So if you go through this page, you can see lots of applications in biology, in medicine, in business, in internet, in world wide web, in standard computer science, also in social sciences, climatology, petroleum, and geology, lots of areas. So clustering as a technique is used in lots of areas, but we will cover few of them, and you can read up about other applications in online. You just Google for applications of clustering in any domain of your choice. So I will take you through two to three examples. So let's take example one. Let's take e-commerce websites like Amazon.com in India, also in US. You have Alibaba in China, eBay, Flipkart, which is very popular and competitive to Amazon in India. You have a lot of e-commerce companies. One of the things that typical machine learning engineer in e-commerce company would apply a clustering tool. It is a problem of grouping. The task could be group similar group to group similar customers based on their purchase behavior. So purchasing behavior could be lots of things like how much money they spend per week or per month, what type of credit or debit card or internet banking they have, how much they typically spend, what type of products will they buy. Of course, using some of these data, e-commerce companies also roughly estimate your income per year. So using all of this purchase data, it can also be geographical data. What is your pin code, and where is your home located, which tells a lot about income levels, your purchasing power, things like that. So if you want to group similar, again, similar is subjective here. So lot of e-commerce companies would like to group similar customers based on their purchasing behavior. So that, suppose if I have a group of my customers into if I group customers into 5 groups, let me say C1, C2, C3, C4, C5. Let's assume 5 groups. It might so happen that for this group of customers C1, we want to offer a deal like for example, in Amazon, something called Prime membership. which provides a lot of features like today delivery, like deals for prime customers, prime video extra. So by grouping customers to one group of by grouping customers to one group of customers, you might want to offer a special deal. Similarly, for one group of customers, you might give a special offer. Let's take 10% off. Let's take 10% off 10% off on some products. Maybe for groceries is something like that. Let it be group C4. So here your task is to group similar customers so that you can make an offer, or you can send an offer over an email or over Amazon app, some deal or offer to the customers, isn't it? Because you believed that these customers have better tendency of taking this deal or taking this offer. So now your task when you are grouping similar customers, here similar basically means that these customers who are all grouped higher potency to take this deal, or higher willingness to take this deal. Similarly, willingness to take this offer or deal. So in e-commerce companies, you do lot of customer clusters so as to send them offers or deals. This is one applications. The second very popular applications of clustering is image segmentation. Let me tell you problem of what image segmentation with an example. The second problem where cluster is extensively clustering is used extensively. This is the problem of, I can say, computer vision and image processing. Computer vision is the area of computer science which try to mimic human visual system. So the computer vision has lot of overlap with machine learning itself. If I just Google image search for image segmentation, I can get this bunch of links. So now one thing you can notice is, so let's understand what is image segmentation. Let's take this image. Now given this image, I have segmented the image into parts. This whole thing is one part, and this one is another part, second part, this one is third part, this one is fourth part, isn't it? So image segmentation is all about grouping pixels or clustering similar pixels to segment segment of objects typically, isn't it? This is an elephant. This is you can see the elephant here, you can see the grass here, you can see the trees, and you can see the sky. Once if your cluster image, if you cluster image into parts. Let's take other image here. If you take this image here, again you are clustering the image into parts where you have grass here, you have sheep, and you have shepherds standing here, and also you can see people standing here. This is also task of clustering. Here let's take one more example, a person on the horse with some background. It takes horse is one object, person is another object, the rest of it is all background. So image segmentation is very important task in detecting images, because when you group or cluster similar pixels, after you clustered them, you typically apply machine learning techniques to perform object detection. So object detection here could be, this is horse, this is a person sitting on the horse, and this is background. So image segmentation is very important and very interesting problem in processing images, which is the core task of computer vision and computer vision and image processing. You are clustering or grouping similar pixels into regions called segments. That's the task of image segmentation. So let's also look at third example, a very interesting example, since we have been seeing this Amazon food review data set, because we have been using it as a running example in our course. In Amazon food review, for each review we have some data about the review and the text. We have some data and text. For each review we have polarity, which is either positive or negative sentiment. How is this data is collected? How this data is collected? Somebody actually read through each of the review text. So let's assume somebody read through the review text. Yes, this first one, review 1 is positive review and review 2 is negative review, and third one is positive review, let's assume. So and so forth. Some human being manually reviewed all of these and labeled the polarity. Here is your polarity means what? Class label. The task is human read all this and manually label this. Somebody gave you this data with polarity of positive or negative, which is very time consuming. Imagine if I have 1 lakh reviews, I need many people to read through each of these reviews and then assign whether it is positive or negative review. It is very time consuming. It is very time consuming, often very costly, because the manpower that we hire, we need to pay them. Forget about 1 lakh reviews. Imagine if I have 1 million reviews, the time it takes or cost it takes to produce the training data, the labels, is super expensive. So for tasks like this, where your manual labeling is time taking or time consuming and expensive, and in cases like this, clustering can be applied. So imagine I have 1 million reviews. I don't have class labels. I don't have YIs here. For this data, I have my XIs. I have only here what I have. I have only XIs. I have data points only, no labels. What I will do as a first step, I will cluster them into 10,000 groups. Let me assume I am clustering them into 10,000 groups. Let's just say based on word similarity. Yes, I am clustering them in 10,000 groups based on word similarity. I will use things like bag of words, TF-IDF, word2vec. I will use all of these syntactic and sometimes stuff together, this syntactic sentiment stuff to group my 1 million reviews into 10,000 groups, isn't it? I have 10,000 clusters. Let me say my clusters are, I have 10,000 clusters, C1, C2, C3, so on. Let me say C 10,000 K means 10,000 clusters. Now I will review and label each cluster. Let's assume I have cluster CI. Take cluster CI. Within cluster CI, I could have hundreds of points. So I will pick 1 point in this cluster. I will pick 1 point in this cluster, and I will see whether it is positive or negative. So let's assume I determine that this 1 point that I picked is positive. Then I will immediately say that the whole cluster, all these points in this cluster, let's give them a positive label, isn't it? So instead of manually reviewing 1 million reviews, I am only going to review 10,000 reviews, which is a massive decrease, which is like 100x reduction in time and cost. Of course, here I am assuming that I can cluster them gracefully. So in the real world, instead of picking 1 point, I will pick maybe few points. Instead of picking 1 point, maybe I will pick 3 or 4 points and I will see all the points are positive. I will give cluster label of positive, and all the points in this cluster give a positive label in the real world. Wherever manual labeling is time consuming or expensive, clustering can be used as a data pre-processing step to group the reviews before you do manual labeling. No, once I have my labels, now I can go. Now I can go and I go ahead to step 3. Now I can train my machine learning classification models, my regression models. This is one other application that seldom discussed. I request you to just go through these applications. If you have any difficulty, please keep a comment. Thank you very much.